Okay, in this video we're going to look at integrating odd powers of sine and cosine and the method for doing this. So the first one we'll start off with the worked example, the sine of x to be cubed. So what is the first step here? And this first step is basically you split this in to the sine squared of x multiplied by the sine of x times dx. So that is the first step. You basically split it into sine squared x times sine x. Then what you have to take into account is the next step we're going to use is this rule, where the sine x to be squared plus cosine x squared is equal to 1. This is standard rule in trigonometry. And if we look at that rule, if we know that sine squared x plus cosine squared x is equal to 1, then we can say that sine squared x is equal to 1 minus cosine squared x. And then the second step, so step number 1 is to split the cube into sine squared times sine x. And then the next step is to substitute in 1 minus cosine squared x for the sine squared x times sine of x dx. And then the next step is to split these into two separate integrals. So this gives me the sine of x dx. So I'll do the first part, where basically it's 1 times the sine of x dx. And then the second one is the integral of cosine squared x sine x dx. So I basically multiply out this term up above. I've kind of done two steps in one here. I've multiplied out 1 minus cosine squared x times sine x, and then I split the two integrals into two separate integrals. Okay, so how do we integrate? If you look at this term is easy to integrate, but how do we go about integrating this one? Well, if you remember earlier in the course, we used the method of substitution. It's for the second questions on the exam paper, question 1b and question 2b. And the basic gist of it here is, if we look at it here, this expression here, sine x cosine squared x dx, is of the type I'm going to get rid of this line I put in here. There wasn't enough room on that side to do it. So it's of the type, the integral of the derivative of f of x times f of x to the power of n. So if you remember doing these sort of questions at the early on in the term, that is equal to f of x plus n to the power of 1 divided by n plus 1 plus the constant of integration. So you're basically saying here, if you remember back when we did these types here, we're saying that this is a product. The sine of x times the cosine of squared of x is a product of two trigonometrical terms, but it just so happens that one of the terms is the first derivative of the other term. So if you look at this and follow the procedure we followed when we did that section before, let's let f of x equal to cosine of x, the bigger function with the power. That means g of x is the other function, which is sine x. Then we get the first derivative of f of x, so that is equal to minus the sine of x. Okay, and that means that a is equal to minus 1 over 1. It's plus 1 over minus 1. It's the coefficient of g at x, which in this case is 1, divided by the coefficient of f prime of x, which is minus 1. But the basic gist of it is that a, the constant, is equal to minus 1. So the question, if we follow our procedure, is a times f prime of x times f at x to the power of n. Sorry, is that equal to g at x? So we put it in. We know it's minus 1 times minus the sine of x. So this is, a is minus 1. We get that by dividing the coefficient of g at x by the coefficient in f prime at x, the coefficient of sine x. We multiply out a times f prime x, and the question is, what's that equal to? It's equal to sine x, and that is equal to g at x, that means we can use this rule. And if we go ahead and use the rule, that says that the integral of sine x cosine squared x dx is equal to cosine x, and the power was 2, so we raise that power to 3 and we divide by the raised power. So what we then do is, if we bring it down here, you can see what I've done here then is we will integrate the integral of sine x to give us minus cosine x, and then we've shown here in red how we work this out, that the integral of cosine squared x times sine x is cosine x cubed over 3, using the method of substitution that we would have covered before earlier on in the semester. Okay, we'll go on and do another question. Even if you're a bit rusty on that, we're going to be doing loads of examples now, so you'll see them practice now anyway. And sorry, I just forgot here that I put a plus here, but of course I forgot to take down this minus here. So in fact it's minus cosine cubed x over 3. Okay, so if we go on to the next example here, it is the integral. We did the sine function, now we're going to do the cosine function. So what we do here is, as before, we split this into 2. So just to clarify this last one, this one here, before we start the next one, the integral of sine x cosine squared x dx, and a is equal to minus 1, so if we got the minus 1 in here, and then if we go back up to our original formula when we integrate them, the integral of sine of x is minus cosine of x, and then we have a minus, and then we substitute in the minus x to be cubed divided by 3 plus a constant of integration. So that gives us minus the cosine x plus the cosine of x to be cubed over 3 plus the constant of integration. So that is the correct form of the equation of the solution. Step number 1 is split the cosine cube function into cosine squared x times cosine x dx. Then, using our standard rule where sine squared x plus cosine squared x is equal to 1, that implies that cosine squared x is equal to 1 minus the sine of squared x. If we substitute that in for the cosine squared x, I'll bring it on to the next line. Substitute that in, we have 1 minus sine squared x times cosine x dx. And here I'll multiply it out as cosine x minus cosine x times sine squared x dx, and then I'll split it into 2 separate integrals. It's cosine x dx minus the integral of cosine x times the sine squared of x dx. Okay, so we have 2 separate integrals here, and then you can see here, once again, we can ask ourselves that, note here, that the integral of cosine x sine squared x dx is of the type, the integral of a times f prime of x times f at x to the power of n dx. So that's the rule we did before, method of substitution. And we say that if that condition holds, then that is equal to the function f at x brought, where you raise the power of the f at x by 1 and you divide by the raised power. So we have to establish, can we use this rule? So first of all, we define what's f prime at x. So we define what's f at x first. So that's the function that's brought to the raised power. So it's the sine of x, and that leaves us with g at x is the cosine of x. The first derivative of f at x is cosine x, positive cosine x. And we're looking to say, is a times the first derivative of f at x equal to g at x, the other function in the product. So what is A? A is the coefficient here of the, if I just make a bit of room here, it's the coefficient of the cosine of x in g at x, which is 1, divided by the cosine of x in f prime of x, which is also equal to 1. So A is equal to 1 in this case. And therefore, we can see straight away that 1 times the cosine of x is equal to g at x. So our condition holds, and that says we can then use our rule, and the rule says that the integral of cosine x sine squared x dx, so in this case this is f at x to the power of 2. So we raised that one, the sine of x. The power there is 2, so we raise it by 1, it becomes 3. We divide by the raised power, and we have a constant of integration. So using these values, I go back up to here, and back up to here, and I'm going to integrate that. So the integral of cosine x is, minus sine x. Is plus sine x, and then it's minus, and the integral of cosine x sine squared x is given here, so it's minus sine cubed x over 3 plus our constant of integration. So that is the final answer in that case. So the first thing we do here is we split this into the sine squared of 2x multiplied by the sine of x, sine of 2x dx, like so. And it's the integral from pi over 4 to 0. The next thing we do, following the standard rule here, that the cosine squared of 2x plus the sine squared of 2x is equal to 1. So it doesn't matter, the rule we had before was cosine squared x plus sine squared x, but you can substitute in any angle there for the x and the rule is still valid. So in this case, if we go to the one above, this tells us that the sine squared of 2x is equal to 1 minus the cosine squared of 2x. So then we're going to substitute that in here. So that's the integral from pi over 4 to 0 of 1 minus cosine squared 2x times sine 2x dx. And I switched to blue there by accident, it doesn't matter. I multiply it out here, so it's pi over 4 to 0 of sine of 2x minus sine of 2x times cosine squared 2x times dx. So I just multiply it out. So step number 1, we split the sine cubed 2x into sine squared 2x times sine 2x. Then we substitute in 1 minus cosine squared 2x in that case, and then we multiply it out, and then we separate it into 2 separate integrals. Pi over 4 sine 2x cosine squared 2x dx. So then, of course, the first one we can integrate quite easily. The second one is tricky, so I'll switch to the red pen where we're doing the second bit. And this says that the integral, and I won't bother with the definite integral, I'll just do the indefinite one for the moment, just to make life easy. The integral of sine of x times cosine 2 squared of x is of the type a times f prime of x times f at x to the power of n dx. And if that condition holds, then a times f, that's equal to f, a times f at x to the power of n plus 1 divided by n plus 1. So that's, we're going to test to see if that rule is valid. So Chematopia was asking there, what do we let fx equal to? It's always you have a product of two trigonometric functions here. It's always the one that's raised to the power. So it's the cosine 2x is raised to a power here. Therefore, g at x is equal to sine 2x. Okay, you get the first derivative of f at x. So it's equal to sine 2x And of course, when you're doing this, you have to divide by the integral, the coefficient of the x. And then we work out our a. So the a, we have sine 2x here, we have sine 2x times a half here. So the integral here is the coefficient of g at x here, and divided by the coefficient of if I take that out, the coefficient of f prime of x is a half. You're dividing by 2, so the coefficient is a half. So if I bring that over here, that's 1 divided by half, like that. So if you remember, we did this before, the dividing by half is the same as multiplying by 2 over 1. So that gives us a is equal to 2. And then the question is a times f prime of x equal to g at x? And that is asking is, for our specific case, is a, we said, is 2 times the first derivative of f at x is sine of 2x. I'm taking from up here, divided by 2. That is equal to sine of 2x, because the 2's cancel. That 2 cancels with that 2. Therefore, it's equal to sine 2x, which is equal to g at x. So we've established, yes, that's true. That means we can use this rule up here. So once we establish that relationship is true, that means that the term without the power is a multiple, is equal to or is a multiple of the first derivative of the function raised to the power. That's the cosine 2x. Once we establish that rule, we can go ahead and integrate it. So that means that the integral of sine 2x cosine squared 2x dx is equal to, our a we said is 2. And what do we say? F at x is, where am I going to? F at x is cosine 2x. The power was 2, so now we raise that to a 3, and we divide by the 3. So it's a bit trickier when you start including the coefficients. So if I come up here now to this, I'm going to go ahead and differentiate this. So that's the integral of sine 2x. So that's equal to minus cosine 2x divided by the coefficient of x, which is 2. And we're going there from the limits pi over 4 down to 0. So I've integrated the first function, and this is equal to the second function. The integral is given here. It's 2 times the cosine cubed of 2x divided by 3. And we're going from the upper limit, pi over 4, down to the lower limit, like so. So if you look at this one, we're doing the definite integral. Before you start doing it, it's more convenient just to work out, plug in the upper limit into cosine here. So cosine 2 times pi over 4. The 2 is divided, the 2 goes into 4 twice, so it's the cosine of pi over 2, which is 0. The cosine at 90 degrees is 0. And the cosine of 0 is 1. So that kind of helps us a little bit when we're working out our integrals. We can bring the half outside if we want, or I leave it inside. It's minus cosine. So the upper limit is pi over 2 divided by 2. The lower limit is minus times minus cosine. And you have to be very careful here because this is a minus. When you do the upper limit, it's minus cosine pi over 2 divided by 2 minus, and then you plug in, open up a bracket for the lower limit, so it's the cosine of 0 over 2. And then if I do the other one, it's cosine of pi over 2 cubed over 3. That's this one up here where I plug in pi over 4. Remember, if I plug in pi over 4, we're getting the cosine of pi over 2 minus 2/3 the cosine of 0 to be cubed. So there's a lot in this, but if you look at this, this one goes to 0 because we said the cosine of pi over 2 is 0. This one goes to minus a half. The cosine of 0 is 1. So it's minus 1 over 2. So here we have minus times minus 1 over 2. So I'll put in here minus times minus a half, and then that's the top one. So I'm going to redo that. Okay, we'll just do it like this. The first one is 0 minus times minus a half. So this one here is the minus a half. Close the brackets. You have to be very careful doing these definite integrals. This one here is 2 divided by 3, and it's 0. Basically that goes to 0 there. And this is minus 2 times 3, and the cosine of 0 here is 1 cubed. So this gives me minus times minus is a plus a half, and here I have minus times minus 2/3, which is plus 2/3. And then if I put those over a common multiple, a half is 2 times 3, the lowest common multiple is 6. 2 goes into 6 3 times, 3 times 1 is 3. So a half is 3 over 6. This one, if I'm converting it to 6, 3 goes into 6 twice, 2 times 2 is 4. And that gives me a final answer there of 7 over 6. So there's quite a lot in that question, and it becomes quite complicated when you have your coefficients of x.